Hi folks, welcome to day 34. Today we'll be starting chapter 9, which is all on simplifying radicals. So remember that a radical is just a square root. So we're going to be talking about simplifying square roots, which is something that you actually began learning about in middle school and the beginning part of trimester 2. All right, so we covered this in trimester 2 as well, so this is going to be a continuation of learning. All right, so with some extra practice. So we learned in chapter 6 all about different properties of exponents and radicals. And one of them is called the product property. Now the product property says if you have two things that are being multiplied inside of a radical or inside a square root, you can break them into two separate square roots. Or the square root of a times b is the same thing as the square root of a times the square root of b. While it might look, pretty easy to deal with when it looks like that, all you have to do is split it up, that's not going to be how our problems actually look like. Our problems are going to look like things like the square root of 27. Now, you can't just plug this into a calculator, right? You're going to get a messy decimal. And we don't like really long repeating decimals, so we're going to be working with how to simplify them. And this is going to this will come into into use. This will be really useful for you when you are working with anything in geometry, so anything involving any shapes, right? In the real world, anything involving shapes, like any buildings, like building anything, whether it's buildings or whether it's construction of carpentry, like building tables and stuff. All of those involve calculations that will have to deal with radicals. So being able to simplify them without a calculator, getting things that are really nice and exact is really important, because you'd hate for, one chair leg to be shorter than the other, right? And so that's why when it comes to simplification of radicals, learning how to simplify them using properties is actually really important. All right. So there are technically two ways to simplify a radical, but the first way is just guessing and checking. Guessing to see, did these two things multiply to be 27? And if so, great, then we can simplify it. But that's not really a very useful way, because it's not very skillful. You're going to waste a lot of time. So I'm going to teach you how to do a factor tree. All right, most of you have done factor trees before. In fact, all of you should have done factor trees before, whether in pre-algebra or at the beginning of this year. All right, but in order to do a factor tree, all you have to do is list out the different factors of the number you're working with. So we're working with 27. So we're looking for different factors or different things that multiply to be 27. You know that 1 is always a factor, because 1 times whatever you're working with is that always gives you whatever you're working with. So 1 times 27 will give you 27. But if you don't know how to do other numbers, well, then you just start listing the numbers out. So if I were to think of, all right, well, let's see if 2 goes into 27. Well, if you don't know your different factors of 2 or your multiples of 2, what you can do is go ahead and pull up your calculator. And if you do 27 divided by 2, all right, this will give you the other number that you would multiply it with. So we have 2 and 13.5. Now, I'm not going to go and write that onto my into my factor tree because it has a decimal. Decimals aren't included in factor trees, only whole numbers. So I'm not going to write my 2. But my next number would be 3. And I know that 3 goes into 27 9 times. Or 3 times 9 is 27. So since all of these things multiply to be 27, that means 27 could be either of those things. Right? That means we could split our 27 into the square root of 3 times 9, or the square root of 1 times 27. All right, but I'm going to let you in on a little secret. Your first step in these problems is to always write your factor tree. Your second step is pick the biggest perfect square of your factors. Remember that a perfect square is just a number that when you put it into a square root, it comes out perfectly. It comes out as a whole number, right? Or said another way, it's whatever the solution would be to a number squared. So like 1 squared is 1. So 1 is a perfect square. 2 squared is 2 times 2, which is 4. So 4 is a perfect square. All right, 3 squared is 3 times 3, which is 9. So 9 is a perfect square. So 1, 4, 9, 16, 25, so on and so forth. Those are all perfect squares. So you're going to pick the biggest one out of your factors. You're going to want to pick the biggest one because if you pick a smaller one, right? So 1 is a perfect square, but so is 9. If I were to pick 1, then instead of 27, or the square root of 27, I would have the square root of 1 times 27, which I would then break up into the square root of 1 times the square root of 27 because of our formula. But the square root of 27 has other factors in it, so it's not factored completely. It's not simplified completely. All right, that's why you always want to pick your biggest factor. All right. Your third step is to go ahead and simplify using the product property. So we already did step 1. We wrote our factor tree. Step 2 is we have to pick the biggest perfect square of our factors. All right. So I know we said we had 1, but that one is not as big as 9, right? So 9 is our biggest perfect square. So we're going to go ahead and simplify the square root of 27 by rewriting it. Instead of the square root of 27, we're going to rewrite it as the square root of 3 times 9. Because 3 times 9, that's the same thing as 27. But if we're going to rewrite it like that, we might as well go ahead and split it up into our 2 radicals. So then we have the square root of 3 times the square root of 9. Now, the square root of 3 does not simplify, right? If you were to plug it into a calculator, you get an ugly decimal. But the square root of 9, we know that that is equal to plus and minus 3. Remember, it's plus and minus because positive 3 squared is 9, or negative 3. So negative 3 squared, which would be negative 3 times negative 3. That's also positive 9, all right? So that's why we have that plus and minus there. So now we're going to replace our square root of 9 with plus and minus 3. So now we have the square root of 3 times plus and minus 3. Our final step is a simplification step, and honestly, it's one that we do just because other people in math do it, all right? But here we have this plus and minus 3, okay? That always goes out in front. Whatever your big number is, that always goes out in front of your radical, all right? So we always write it as plus and minus 3 times the square root of 3, okay? So we write it like that because it's then easier to see what the numbers are outside versus inside. Because remember, most of the time, this step here would be written as the square root of 3 and then plus and minus 3. But some of you, especially when writing by hand, some of you write too long. Well, you got to remember, we didn't always have computers, so they always have this plus and minus 3. The whole numbers are always in front, so that way they don't get mistaken for being underneath a radical. This is really, really important because I'm going to need to see your whole numbers in front of your radicals on your quizzes and on your tests. So that way I know that you aren't thinking that it's inside of the radical, because it's not. It's outside, right? It's outside the square root. That's why I also have this little piece that I draw down just because it makes it a little bit easier to see exactly where your radical ends. All right? So that's all you have to do in order to simplify a radical. All right? So you have 4 quick problems to try out. Actually, I think you might only have 3 quick problems to try out. If you felt like this wasn't enough and you want a little bit more explanation, feel free to check out my paper notes. All right, my written notes do have, I think, at least 1 extra example in them. So it's like a different example than this one. So you can always make sure that, you're checking out all of your different resources. All right, and keep in mind, if you ever get stuck, you can always email me. All right, it's not like, you're on your own. One final note I will say is if you had something like a negative outside of the square root, so we have the negative square root of 27, that negative just comes along for the ride. So then it would change all of our answers, right, in terms of our work. Instead of square root of 27, we have negative square root of 27. We'd have a negative sign out here, a negative sign out here, which would then make this only a negative sign. All right? So just as a heads up, that is something that you might run across. But as a whole, these 3 steps, writing out your factor tree, picking the biggest perfect square among your factors, and then simplifying using the product property, that's all I'm looking for today. All right? Best of luck on that assignment for you, okay? Let me know if you have any questions on that.